same speed, same displacement from the rest positions. As you can see from the diagram, P, S and V all are the crust points. So they will move with the same speeds, they are in the same displacement, they are moved the same direction, so they are in phase. And R and U, they are the phase, and Q and T, they are in phase. Now, what is wavelength? The wavelength is the shortest distance between any two points in phase. Now, the P and S point, the distance is the wavelength. Q and T is the wavelength. R and U is also the wavelength. Okay. Now, next, about the frequency. The frequency F is the number of waves produced in 1 second. So if there are 10 waves passing through a point in 1 second, the frequency will be 10. If there are 5 waves, then it will be 5. So its unit is hertz. The period T is the time taken to produce one complete wave. And the SI unit of period is second. And its formula T is equal to 1F is used many times in solving questions. And we will also use it, girls. Next is about C, the question, that there is a dipper in a ripple tank at T is equal to 0 at water surface. It is at rest. When dipper at T is equal to 1 second, the direction of travel is there. You have to count the number of waves here. That is one crust. That is one crust and one trough. One crust and one trough. 2, 3, 4 and 5. There are 5 waves. So 5 waves produced in 1 second. So frequency is 5 hertz and period is 1 by 5, 0.2 second. Now what is wave speed? Now wave speed V is the distance traveled by a wave per second. In one period, what is distance moved by a wave crust? That is, speed of a wave is given by the formula distance traveled by one wave divided by time taken, and that distance traveled will be equal to the wavelength. So the wave speed is equal to wavelength over period. So V is equal to lambda by T. Now we know that 1 by T is equal to F. Now the equation we got is V is equal to F lambda. Now this is the formula for the speed of the waves. Okay, next. This is our displacement distance graph. It is a very important graph. We have to do many calculations by using this graph, in which the displacement is along y-axis and distance is along the x-axis. Now you can see the displacement gives you the amplitude also, so we can find the amplitude of the wave, and displacement, distance gives the wavelength, that the distance covered by the wave in 1 second. We can find these two values by the use of this graph. Now the displacement time graph, when we plot the time along x-axis and displacement along the y-axis, then we can determine the values of displacement as well as time from this graph. Now we can also find time period of the wave by using this graph as well as the amplitude. As you can see in the diagram, the period of the graph is equal to the distance between the crust and trough and two consecutive points. Amplitude is this. Here the amplitude is 5. And the wavelength of the wave is 1, as you can see. Okay, sorry, time period of the wave is 1 second. Okay, now up to now what we have studied about wave front, amplitude, wavelength, frequency, period, wave speed, and we have studied about two graphs, displacement distance graph and displacement time graph. Okay, this is a question for you girls. You have to practice it, solve it, and I also have given you the solutions so that you will not find difficulty in solving it. But don't cheat, please. Do it very honestly. You can do it just by a little practice. They have given you speed, time. You have to draw the label and the graph position of P and Q at T is equal to 3 seconds. There is another question given to you. A wave in a string is traveling to the right at 2 meters per second. The diagram below shows its displacement graph at T is equal to 0 second. You have to plot a graph to show how the displacement of particles P and Q vary with time. Now this is the question. This is all over the assignment. This is the solution. Thank you so much, girls. I hope that all of you have understand